Hey guys, tonight we open the ceiling of the ordinary world and look up into a darkness sprinkled with quiet stones, each one gliding through the cold like it is all the time in the universe, which, to be fair, it more or less does. You can picture them now. Not screaming fireballs, not the dramatic end of all snacks and schedules, but ancient pieces of the solar system drifting with an almost rude level of calm. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And while you settle in, tell me your location and local time, because I love imagining all of us listening from different corners of the spinning earth, tucked under blankets, near windows, under fans, beside city noise, or deep country silence. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You begin with a simple image, a night sky that looks empty until you know better. Space is very good at pretending nothing is there. It puts on this huge velvet performance, all stars and silence, while countless smaller things move invisibly through it with the patience of monks and the social ambition of introverts at a wedding. Asteroids are among those things. They are rocky bodies, sometimes metallic, sometimes dusty, sometimes oddly shaped like somebody tried to sculpt a potato during a power outage and then just committed to it. They orbit the sun, and they have been doing so for such absurd stretches of time that human deadlines begin to look like little soap bubbles. The relaxing part starts almost immediately once you stop expecting them to behave like action movie props. Most asteroids are not racing toward you with malicious intent. They are not plotting. They are not waiting for the perfect moment to ruin a Tuesday. They are simply there, following paths shaped by gravity, sunlight, and the long memory of the solar system. If planets are the grand architecture of the heavens, then asteroids are the old stones left in the garden paths, the bits that were never swept away, the fragments that remain because the universe, like every household with a mysterious drawer full of cables, keeps more leftovers than you'd think. You can think of an asteroid as a small world that never became a world in the full glamorous sense. It is a body too small to round itself neatly into a planet, too independent to be just dust, too ancient to be called debris without sounding disrespectful. Some are only a few meters across. Some are hundreds of kilometers wide. Some are dark as charcoal. Some shine more brightly. A few are made with enough metal to make them feel like sunken treasure chests drifting through black water. And all of them, even the most unimpressive little lump, carry something soothing. They're survivors from the beginning. That idea alone can slow your breathing a little. These stones are old beyond ordinary imagination. Long before there were forests, oceans, birds, cities, playlists, awkward text messages, or the invention of socks that vanish in the wash, there were asteroids. They were present when the solar system was young, when the sun had only recently switched on in cosmic terms, and all around it the leftover material of creation was still sorting itself out. To look at an asteroid, even in a photograph, is to look at matter that remembers the first rough draft of our neighborhood in space. It is ancient without being theatrical. It does not need a speech. It just exists. And maybe that is part of why the topic feels so restful. Asteroids are reminders that not everything in the universe is trying to become something bigger, shinier, or more important. Some things remain exactly what they are for billions of years and still matter immensely. In a world that constantly asks you to optimize, improve, brand yourself, update your software, hydrate more aggressively, and somehow become a better person before next Thursday, there is comfort in a drifting rock whose main achievement is continuing calmly along its orbit. Honestly, that is a lifestyle. If you were somehow able to float far above Earth and watch the solar system from a generous distance, you would not see chaos. You would see motion, yes, but motion with memory. Asteroids loop around the sun in paths that can be calculated, traced, anticipated. They are not random pebbles tossed into the dark. They belong to the same elegant gravitational dance as the planets. Even the ones with stranger orbits are still part of the choreography. They arrive where physics expects them to arrive. They turn when gravity tells them to turn. They keep time without clocks. And because they are so numerous, they offer a special kind of calm through scale. There are millions upon millions of asteroids, perhaps more than your mind wants to comfortably host before bedtime, and yet the solar system does not feel crowded. That is one of the gentlest facts of space. It is lavish with room. You can have countless objects moving for ages without them constantly colliding like shopping carts in a supermarket parking lot. Space gives everything breathing room. Even the rocks get personal space, which feels like a policy we could bring down here. People often imagine asteroids as dangerous because the word itself comes with a certain cinematic baggage. It arrives wearing dramatic music. But the truth is much quieter. Most asteroids spend their entire existence far from Earth, minding business, so private it barely qualifies as business at all. They travel in regions where they are one small part of a much larger, more serene pattern. Even when some pass closer to Earth, astronomers usually know about them, track them, name them, and follow their routes with the calm competence of people who genuinely enjoy spreadsheets and the night sky in equal measure. There's something deeply reassuring about that, too. The sky is not just watched, it is known. So you let your imagination adjust. Instead of a threatening rock, you picture an object moving soundlessly through sunlight. The sun is far away, but still enough to illuminate one side while the other remains in shadow. No wind scrapes its surface. No rain smooths it. No birds land on it and decide the branch selection is terrible. It simply turns, perhaps slowly, perhaps tumbling a little, carrying craters and scars and mineral veins across the dark. It is silent in a way almost nothing on Earth is silent. Not the silence of absence, but the silence of endurance. That kind of silence can feel medicinal. Here on Earth, nearly everything is announcing itself. Phones glow, appliances hum, traffic negotiates with itself. A neighbor somewhere makes a bold and confusing furniture decision after midnight. Even your thoughts can act like a committee that has forgotten the agenda. But asteroids do not argue. They do not market themselves. They do not set alarms. They drift under the rule of gravity and time. And in doing so, they offer you a picture of existence stripped down to essentials. A rock in space does not need to be pretty to be beautiful. In fact, asteroids are often most lovable when they are slightly ridiculous. Many are lumpy, asymmetrical, and endearingly awkward. They do not resemble polished marbles from a luxury cosmic showroom. They resemble the first attempt, the leftover batter, the strangely formed biscuit that still tastes perfect. The universe, it turns out, has room for irregular things. It does not insist on symmetry before granting wonder. That is excellent news for asteroids, and frankly encouraging for the rest of us. The more you look into them, the more they start to feel like a hidden layer of reality, a scattered archive of beginnings. They are not stars, yet they travel among starlight. They are not planets, yet they share the sun. They are small enough to seem humble, old enough to seem wise, and numerous enough to change how you imagine the sky. Once you know they are there, the darkness feels fuller, richer, less empty. The night becomes populated not only by distant blazing suns, but by quiet companions of stone. And there is a sweetness in knowing that while you lie here listening, while your room settles and your eyelids grow heavier, somewhere out there an asteroid continues along a path it has followed for ages. It is not in a hurry. It has never been in a hurry. It does not care what day it is, what year it is, or whether you answer that email. It circles the sun with a steadiness so old and so complete that your own pulse, your own breath, can borrow a little of its rhythm. You do not have to chase the universe tonight. You can simply notice that it keeps moving beautifully without any help from you. So you stay with that feeling. Ancient stones gliding through the dark. Not chaotic, not cruel, not loud. Just present, just patient, just part of the deep architecture of a cosmos that contains both blazing stars and these quieter relics, these small, persistent bodies that never ask to be center stage. They are enough exactly as they are: fragments, wanderers, leftovers, witnesses. And beneath them, on this turning Earth, you get a rest for a while under their invisible company, comforted by the gentle fact that so much of the universe is not dramatic at all, only vast, steady, and quietly, unbelievably calm. You hold on to that image of the patient stones circling in darkness, because the next calming truth is that asteroids are not random junk flung carelessly around the solar system. They're leftovers, yes, but leftovers in the most beautiful sense. Not garbage, not cosmic clutter, more like the last bits of dough on a baker's table after the loaves have already gone into the oven, still carrying the same ingredients, the same warmth of origin, the same memory of being part of the making. And the early solar system, despite sounding grand and orchestral, was also a place of leftovers. A very large, very glowing kitchen, really, and one with essentially no concern for your countertop cleanliness standards. You can picture it long before Earth had oceans, or moonlit fields, or sleepy people checking the time for bed. A cloud of gas and dust had collapsed under gravity. At the center, the sun began to gather itself, to heat, to brighten. Around it spread a wide disk of material, all of it orbiting, all of it colliding, clumping, sticking, breaking, reforming. Not neat. Never neat. The universe almost never begins with neat. It begins with swirls, with fragments, with particles meeting particles, with grains finding grains, with little bits joining into bigger bits until the bigger bits begin to matter to gravity in a new way. And that is where asteroids become unexpectedly comforting, because they belong to the part of the story before everything looked finished. They are witnesses from the era of becoming. Tiny mineral grains in that spinning disk bumped together and formed pebbles. Pebbles met other pebbles, and some became boulders, and some larger clusters became planetesimals, the first meaningful building blocks of planets. That word alone feels like it should be wearing tiny boots and trying its best. Planetesimals, small bodies with a serious future, or at least a strong possibility of one. Some of those bodies kept growing. Gravity helped them collect neighbors the way certain people at parties accidentally become the center of the room without meaning to. They gathered more mass, and more mass gave them more pull, and more pull let them gather still more material. Over time, those fortunate winners grew into protoplanets, and eventually into the worlds you know: Earth, Mars, Venus, and the rest of the full-size celebrities of the solar system. But not every object got that lucky. Some remained small. Some were disrupted. Some formed where Jupiter's immense gravity kept the neighborhood too restless for easy planet making. Some simply stayed as they were, ancient and unfinished, preserved instead of promoted. And that is one of the most restful facts about asteroids. They are not failures. They are records. It is easy, with your very Earth-style brain, to imagine that if something did not become a planet, it somehow missed its chance, like a contestant voted off a truly unreasonable reality show called So You Think You Can Accrete. But that is not what happened. Asteroids endured. They remained close to their original nature. They kept the old ingredients. Many of them changed less than planets did. Earth melted, churned, separated into core and mantle and crust, became geologically active, acquired atmosphere, oceans, weather, life, and eventually tax forms. Asteroids, by contrast, often stayed simpler. They did not evolve into busy worlds. They kept more of the solar system's childhood in plain sight. That simplicity is deeply soothing. Imagine holding a stone that has not been recycled by mountains, rivers, roots, or tectonic plates, but instead has remained a quieter relic of formation itself. Many asteroids preserve the chemistry of the early solar system with a kind of stubborn honesty. Some contain materials that condensed near the beginning, tiny mineral grains among the oldest solids known to have formed around the young sun. Some preserve clues about heat, water, organic compounds, and the slow physical processes that shaped everything later. They're modest on the outside and secretly archival on the inside, which is a personality type many people find relatable. The process that made them was not sudden. That helps too. The solar system did not arrive in one dramatic flourish. It assembled gradually, through repeated encounters, through contact and patience and gravitational persuasion. A dust grain met another dust grain. A pebble found a pebble. Bodies collided softly at first, then less softly, because nothing says universal creation like an escalating series of impacts. But even that violence, when looked at over immense timescales, becomes part of a larger order. Matter was sorting itself. The same physics that let worlds form also let some fragments remain. There was room in the plan, if you can call it a plan, for both planets and leftovers. And leftovers can be the best part. Everyone knows this. Soup on the second day. Cake after the frosting settles. Rice that somehow tastes wiser. Asteroids are like that. They carry the original material of the solar system in a state less processed than planets. They did not all get melted down and remodeled. Some stayed cool enough, small enough, distant enough, or isolated enough to preserve what came before. So when scientists study asteroids, they're not just admiring rocks because they have a very advanced hobby problem. They're reading preserved notes from the beginning of everything nearby. You can almost feel the calm of that preservation. The young solar system was full of possibility, and these little bodies kept pieces of it. Metals, silicates, carbon-rich compounds, perhaps even traces of water-bearing minerals in some cases, all tucked into bodies that drift for eons. They're like pantry jars from the first cosmic kitchen, still labeled in a language of chemistry and time. Some jars got spilled into planets. Some were baked into moons. Some sat undisturbed on the shelf. And now, billions of years later, you can look up and know those original ingredients are still out there, circling quietly under sunlight. Even the fact that planet formation was messy becomes relaxing when you give it enough scale. There is comfort in realizing that the elegant solar system you learn about in diagrams began as a cloud of chaos. Things did not need to start cleanly to become beautiful. They did not need every collision to work out perfectly. The result you live in now, stable orbits, seasons, tides, the moon, the possibility of lying down and listening to stories about asteroids, came from a process that included jostling, fragments, and incomplete growth. So the asteroids are not embarrassing leftovers hidden after company arrives. They are part of the honest story. They reveal that creation keeps its rough drafts. And rough drafts are often where the tenderness lives. A finished planet can feel a little formal, a little proud of itself, rotating there with atmosphere and geology and perhaps the occasional volcano just to show off. But an asteroid has a humbler charm. It says, I was here when things were being made. I remember the crumbs on the table. I remember when nothing had settled. I remember when the sun was young and all of us were just trying to stick together. There is no vanity in that, only endurance. The region where many asteroids remain, especially between Mars and Jupiter, owes some of its character to the huge presence of Jupiter, whose gravity stirred the material there enough to interfere with easy planet building. So even the giants of the solar system had a hand in preserving these smaller bodies. Jupiter, enormous and dramatic in its own right, became the accidental guardian of unfinished worlds. It is almost funny, the biggest planet helping keep the little rocks from growing up. Cosmic overparenting, but useful. As time passed, collisions shattered some asteroids and created families of fragments. Heat altered some, impacts scarred many. But despite all that, the basic truth remains serene. Asteroids are among the most direct physical reminders of how everything here began. Not as a polished set, but as a gathering. Not as perfection, but as accumulation. The solar system was assembled from whatever it had, and these objects still carry that original inventory. There are bits that escape being fully rewritten. So when you think of asteroids now, you can think of them as the calm crumbs of creation. They never became full planets, and that is exactly why they are so valuable. They let you peek beneath the finished surface of the solar system and see the older layer, the one where stone and metal and dust were still deciding what to become. They are unfinished in the gentlest possible way, and there is something lovely in that. The universe did not discard them. It kept them. It let them go on circling, carrying the chemistry of beginnings through the dark. And maybe that is why their existence feels strangely reassuring at the end of a long day. They remind you that becoming is not the only noble state. Remaining can be noble too. Holding the old pattern can be noble. Keeping the first ingredients safe for billions of years can be noble. The solar system did not only produce grand planets and glowing stars. It also kept these quieter pieces, these unfinished stones, these patient leftovers that still whisper how the whole thing started. And while the world around them changed, melted, weathered, and evolved into ever more complicated forms, the asteroids stayed close to the beginning, moving softly through space with all the calm of something that never needed to become anything else. You keep that sense of unfinished, preserved matter in your mind, and then you move outward into one of the most misunderstood places in the solar system, which is honestly impressive because the competition is fierce. The asteroid belt has been treated so unfairly by movies that if it had a lawyer, it would have an excellent case. Popular imagination likes to picture it as a frantic tunnel of tumbling boulders packed so tightly together that any spacecraft entering it would need the reflexes of a caffeinated dragonfly. Alarms would blare, pilots would squint, things would explode for no scientific reason except audience morale. But the real asteroid belt is far calmer, far emptier, and somehow far more soothing than that. You can picture it lying between the orbits of Mars and Jupiter, a broad region circling the sun like a quiet band of memory. Not a wall, not a storm, more like a vast ring where many ancient bodies travel on their own paths, each with an extraordinary amount of personal space. That is the secret that makes this part of the story so relaxing. The belt sounds crowded only because you're used to Earth-sized distances, Earth-sized rooms, Earth-sized roads, where 3 people in a hallway can somehow become a diplomatic incident. Space does not work like that. Space is enormous in a way that makes plenty of room seem like the understatement of several millennia. If you were standing on an imaginary observation platform high above the solar system, watching the asteroid belt as a whole, you would see something graceful rather than chaotic. Countless objects would be orbiting the sun, yes, but spread across a huge volume of space. The gaps between them are immense. Even in the denser regions, the average asteroid is usually separated from the next by distances so large that the belt is mostly emptiness with occasional rocks, not rocks with occasional emptiness. It is less a traffic jam and more a long, unhurried flow of solitary travelers on a very wide, circular road where no one tailgates because everyone is separated by the cosmic equivalent of several neighborhoods. That emptiness is one of the nicest facts you can hand to an anxious brain. The asteroid belt is not a claustrophobic mess. It is a lesson in how calm motion can be when there is enough space for it. You could pass through it in a spacecraft, and statistically speaking, your biggest challenge would not be dodging giant boulders every 4 seconds. It would be maintaining the correct course and try not to be too emotionally attached to movie nonsense. Space agencies have sent spacecraft through the asteroid belt without needing some swashbuckling obstacle course sequence. The rocks are there, but they are not stacked like a badly organized pantry. And the belt itself is not random. It has structure. It has neighborhoods, families, resonances, and patterns shaped by gravity over billions of years. Some regions contain more asteroids. Some contain fewer because Jupiter's gravitational influence creates orbital resonances, areas where repeated gravitational nudges could destabilize objects over time and clear out lanes. These are called Kirkwood gaps, which sounds much cozier than zones where gravity keeps making your orbit weird, though both are accurate in spirit. The result is a belt that is not just sparse, but patterned, with invisible architecture laid down by motion itself. That idea can be wonderfully calming if you let it settle. Even in a place full of leftover stones, there is order. Even in a region born from interrupted planet formation, there are rules, rhythms, and elegant absences. The gaps are not mistakes. They are part of the design written by gravity and time. Jupiter, that enormous gas giant with all the subtlety of a cathedral falling through fog, has shaped the belt from afar, not by smashing through it like a cosmic wrecking ball, but by tugging with patient repetition. One orbit, then another, until certain paths become less stable and the belt arranges itself accordingly. The asteroids themselves vary from tiny fragments to dwarfing presences like Ceres, Vesta, Pallas, and Hygeia, each with its own character. Ceres, the largest body in the belt, is large enough to count as a dwarf planet, which gives it a certain quiet dignity, like the eldest cousin at a family gathering who has transcended the need to prove anything. Vesta is bright and geologically fascinating, with a huge impact basin that makes it feel like it has seen things and chosen composure anyway. Pallas moves in a more tilted orbit, a bit like the slightly eccentric relative who always arrives from a different direction. Hygeia rounds out the larger residence with a gentler, darker presence. Around them travel vast numbers of smaller bodies, many belonging to families created when ancient collisions broke parent asteroids into related fragments. But even collision families, when viewed from enough distance, do not make the belt feel violent. They make it feel historical. These are records of events that happened long ago, their fragments continuing onward in shared orbits like relatives who inherited the same odd cheekbones and the same tendency to avoid eye contact at reunions. The belt is a place where old impacts are still legible, not because they are currently dramatic, but because the evidence remains. Time and space does not erase everything. Sometimes it simply spreads the pieces out and lets them keep going. And that spread, that width, that sheer generosity of room is what softens the whole region into something almost meditative. You imagine each asteroid moving in silence, warmed on one side by the sun, casting a tiny shadow, continuing through the dark with no need to hurry and no need to crowd. No air, no sound, no weather to push it around. Just inertia, gravity, and long obedience to orbital law. It is deeply peaceful. The belt is busy only in the most patient sense of the word. It is active the way a clock is active, or a tide is active, or a field of grass is active under moonlight when the wind is too gentle to hear. This is one of those places where the truth is not only less dramatic than fiction, but lovelier. A packed corridor of flying doom would be memorable, certainly, but a broad, quiet region of ancient stones, each tracing a stable path through impossible distances, is the kind of fact that helps your heartbeat loosen its grip a little. You do not need everything in the universe to be exciting. Sometimes it is enough that it is orderly. Sometimes the greatest comfort is that reality, when stripped of theatrical exaggeration, is calmer than the stories we tell to wake ourselves up. And the belt has been there for an astonishingly long time. A durable band of leftover building material that never became a planet because the environment there, shaped so strongly by Jupiter, remained too dynamically restless for one body to gather everything up. So instead of one polished world, the region kept many smaller ones. It stayed plural. It stayed granular. It became a museum of persistence rather than a monument to completion. There is something restful in that too. The solar system did not insist on resolving every region into a single neat outcome. It allowed this one to remain a collection. When spacecraft visit the belt, they are not plunging into instant peril. They are entering a realm of careful navigation, yes, but not panic. They travel through a place where the danger comes less from constant near misses and more from the general reality that space is difficult because everything is far away and engineering is a humbling profession. The belt receives visitors with the same calm it offers everything else. It does not lunge. It does not snarl. It simply continues, a huge ring of motion suspended in blackness, maintaining its patient traffic around the sun. You might even find yourself liking the phrase main belt for its plainness. Not the death belt, not the screaming corridor, the main belt. It sounds like a practical piece of clothing, something your sensible cosmic aunt would recommend before a long journey. And in a way, it fits. The main asteroid belt is a standard feature of our solar system, not an emergency. It is part of the layout. It belongs where it is. It tells the truth about how the solar system formed, and it does so without any special effects. So as your mind moves through this region, you can let go of the cluttered images and keep the real one instead. A vast ring between Mars and Jupiter, full of ancient objects but fuller still of silence and distance. Rocks drifting with room to spare. Invisible lanes shaped by resonance. Large bodies keeping their dignified circuits. Smaller fragments belonging to old families. Not chaos, not panic. A place where motion has been refined by time into something nearly serene. And maybe that is the quiet gift of the main belt. It teaches you that a place can contain countless objects and still feel spacious. It teaches you that old collisions can settle into long-term order. It teaches you that what looks alarming from a distance of ignorance may become beautiful once you understand the scale. The belt is not the universe trying to scare you. It is the universe demonstrating that even its leftovers can organize themselves into elegance, leaving wide, silent intervals between one ancient stone and the next, enough distance for light to pass, enough distance for thought to rest, enough distance for you to breathe a little more slowly under a sky that is far calmer than it first appears. You carry that wide, quiet spaciousness of the main belt with you, and then the next delightful truth appears almost like a smile in the dark. Asteroids are often gloriously, unapologetically odd-looking. Not majestic in the polished way planets are majestic, all-round and self-important, and clearly aware they have been included in textbooks. Asteroids are different. They look improvised. They look like objects the universe made while absent-mindedly stirring the leftovers from planet formation with one hand and adjusting Jupiter with the other. And somehow that makes them even more lovable. If you grew up with the idea that celestial bodies should be perfect spheres, smooth and noble and ready for their portrait, asteroids are here to gently ruin that expectation in the best possible way. Many of them are lumpy. Some are elongated. Some look like squashed potatoes, chewed pebbles, stacked boulders, or two separate rocks that collided so softly and so patiently that they eventually just decided to remain together forever. There is no shame in any of this. Space, very refreshingly, does not enforce symmetry as a condition for wonder. That is one of the most relaxing facts you can hold tonight. In the vastness of the solar system, there are ancient objects shaped less like geometric ideals and more like things found in the back of a garden shed. And still they orbit. Still they matter. Still spacecraft travel enormous distances just to visit them. The universe does not require perfection before granting significance. It lets a misshapen rock be ancient, beautiful, and scientifically priceless all at once. That feels generous. The reason for these strange shapes is wonderfully simple. Many asteroids are too small to pull themselves into spheres. A large planet has enough gravity to tug all its material inward until it rounds out. The way dough settles into a smoother form if there's enough mass and softness involved. An asteroid, especially a smaller one, does not have that luxury. Its gravity is weak. Its material can remain distributed in all sorts of awkward ways. So instead of becoming a polished ball, it keeps the shape given to it by its history. Collisions, fractures, mergers, lost fragments, accumulated rubble, maybe the occasional dramatic insult from a passing impactor billions of years ago. And history, as usual, is not neat. Some asteroids are monolithic, more like single solid bodies, But many seem to be what scientists call rubble piles, which is such a charmingly honest term. Not celestial cathedrals, not monolithic monuments. Rubble piles, collections of fragments held together by their own weak gravity after earlier collisions shattered a parent body. Imagine an object broken apart long ago, its pieces slowly settling back together in a loose gravitational embrace, like a bag of rocks trying its best to pass as one rock. That is not only real, it is common. The asteroid survives, but in a changed form, a loosely assembled survivor wearing its scars as structure. That makes their surfaces and silhouettes wonderfully varied. One may have a long body with a narrow middle, like a cosmic peanut. Another may appear flattened, as though gently pressed by an invisible thumb. Another may be irregular in every direction, with ridges and depressions and protruding boulders that give it the appearance of something assembled from memory rather than from blueprints. You can almost sense how little interest the universe had in making these things presentable for the brochure. And bless it for that. There's a particular comfort in the examples humans have actually seen up close. When spacecraft visited asteroids, they did not uncover rows of pristine marbles floating in mathematical dignity. They found character. Eros, for example, is elongated, stretched out like a worn river stone that has had a very long life and no spa treatments. It looks ancient because it is ancient, but it also looks slightly practical, as if it might know where the spare batteries are kept. Ithaca appears even stranger, with two lobes connected in a way that gives it the look of a squashed sea creature or a gravelly space peanut. Bennu and Ryugu, both visited by sample return missions, have their own rough, almost diamond-like forms, with surfaces scattered by boulders and loose material. None of them look factory-made. All of them look real. And real, at bedtime, is often kinder than ideal. Ideal things can feel distant. Irregular things feel companionable. A lopsided asteroid does not intimidate you with perfection. It invites you to appreciate survival. You can look at those shapes and understand, almost immediately, that these objects have endured collisions, solar heating, gravitational nudges, and billions of years of orbital life without ever needing to become elegant by conventional standards. Their beauty is not in refinement. It is in persistence. Some of the most charming are the contact binaries, which are asteroids made of two lobes that seem to have come together gently enough to remain stuck. They look like the universe invented snowmen, but ran out of snow and used stone instead. There is something absurdly tender about that possibility. Two bodies meeting in space is not always catastrophic. Sometimes, under the right conditions, they join softly enough to keep both identities visible. A narrow neck, two distinct bulges, one shared future. It is cosmic compromise, but sleepy and adorable. This also means that the closer you look, the more each asteroid becomes a portrait of its past. A crater here suggests an impact long ago. A sharp ridge there may hint at fragments settling. Giant boulders on the surface may have been tossed up by old collisions or simply remain from the rubble that reassembled the body. Some asteroids are so dark they seem to absorb light with introverted efficiency. Others are brighter. Some look dusty. Some look metallic. Some look like they were assembled from broken masonry by a committee with admirable patience and no design experience whatsoever. And still, even with all that variety, there is calm in the pattern. These forms are not random in the meaningless sense. They are the outcome of physical laws acting over time. Weak gravity, repeated impacts, reaccumulated material, rotational effects, internal structure. Each odd contour has reasons behind it. The shape may look whimsical, but it is not arbitrary. That is one of the more soothing lessons hidden inside asteroid science. Even strange things often have understandable origins. Weirdness is not chaos. Weirdness is history made visible. You can linger on that for a while. A potato-shaped asteroid is really a timeline you can look at. It says this body was too small to become round. It says collisions mattered. It says gravity was present, but gently. It says time was long. It says the solar system does not smooth away every wrinkle. That message can feel unexpectedly reassuring. Your own life, after all, is not a sphere, is not neat, not symmetrical, not evenly lit from every angle. And yet it is still a real thing, carrying history, shaped by impact, held together in places by forces softer than you expected. Some asteroids even tumble in ways that make their shape feel more personal, though you do not need to get ahead of their motions just yet. It is enough tonight to imagine a crooked object slowly presenting different sides to the sun, its ridges and hollows taking turns in the light. One moment a low glows, another slips into shadow. A crater becomes visible, then hidden. The same body looks different depending on the angle, which is another tender little truth. You're never seeing the whole of it at once. No one is. Even a rock in space gets to keep a few private faces. And the scale of these shapes adds to the quiet awe. Some asteroids are small enough that if you stood on one, assuming an absurdly cooperative spacesuit and a complete disregard for ordinary logistics, you could almost take in its whole form as a landscape and an object at the same time. A ridge would be both a horizon and a wrinkle. A boulder would be both a feature and a clue. On a small asteroid, shape is not an abstraction. It is the place itself. The entire world is one oddly formed thought of stone, and you could cross from one end to another without needing continents, oceans, or a weather forecast. That smallness makes them feel intimate. Planets can be overwhelming. Asteroids can feel knowable. A whole body with all its quirks, all its topography, all its silly and noble asymmetries can be mapped, studied, even sampled. Human curiosity can hold the outline of such a thing in mind. You can learn its contours the way you learn the face of someone familiar. Here's the lobe. Here is the ridge. Here is the crater chain. Here is the narrow neck. Here is the side that catches more light. The object stops being a generic rock and becomes itself. And there is something very peaceful about a cosmos populated not only by giants, but by these humble oddities. It makes space feel less like a gallery of ideal forms and more like a place where history leaves fingerprints. The asteroids did not need to become round to be ancient. They did not need to become smooth to be worthy of study. They did not need to become majestic to become memorable. They are enough with their dents, bulges, necks, knobs, and improbable silhouettes. So you let the polished image of the heavens relax a little. You allow the solar system to include lumpy survivors and misshapen elders. You picture them in the dark, each one carrying its own contour like a quiet biography, each one shaped by billions of years and still perfectly accepted by the universe that made it. The planets may pose for the portraits, but the asteroids keep the charming honesty of the rough sketch. And sometimes the rough sketch is what you trust most, because it has not been polished into performance. It has simply remained what it is, ancient stone, imperfect and enduring, turning its strange beloved face toward the light a little at a time. You keep that rough, beloved silhouette in view, and then something even softer begins to reveal itself. These irregular little worlds do not simply exist out there like paperweights on a shelf. They turn, they spin, they wobble. They offer themselves to sunlight one face at a time. And in doing so, they create the closest thing an airless stone can have to a daily rhythm, which is honestly impressive for something that looks, in some cases, like a peanut assembled by gravity during a light administrative crisis. Rotation is one of the gentlest ways to imagine an asteroid because it changes the object from a static lump into a quiet participant in time. Even in deep space, where there is no wind, no weather, no chirping birds making it everybody's business that dawn has happened, an asteroid still has a kind of morning and evening. One side turns toward the sun and warms. Another falls into shadow and cools. Ridges brighten, craters darken, boulders cast sharp black shapes across the surface. Then, slowly or quickly, depending on the asteroid, the pattern changes again. Light moves. Heat shifts. A new face turns into day. Some asteroids spin in only a few hours. Some rotate more slowly. A few turn in a languid way that makes you feel as though the entire solar system has quietly agreed to lower its voice. The exact pace depends on their size, structure, history, and whether past collisions or steady forces from sunlight have nudged them over time. But whatever the rate, the basic image remains soothing. Ancient stone, carrying its own tempo through darkness, never rushed, never late, never checking whether its calendar app synced correctly. And because so many asteroids are irregularly shaped, their rotation is not always neat in the way a tidy classroom globe spins on its stand. Some rotate around a fairly stable axis. Others wobble. Some tumble in what is called non-principal axis rotation, meaning they do not spin in the clean, elegant manner you might have hoped for if you're the sort of person who alphabetizes spices and believe the universe should at least try harder. These tumbling asteroids rotate in a more complicated way, as if they are slowly reconsidering which end is up. Yet even that is not chaos. It is motion with rules. Physics still knows what is happening, even when the object appears to be having an existential shrug. That wobble is strangely comforting too. Not every body in the solar system is a perfect spinning top. Some are more like a sleepy object rolling in a pocket of gravity, finding its own awkward equilibrium. Their motions can be complex, but complexity is not the same as panic. A tumbling asteroid may keep tumbling for very long times, carrying its uneven spin across millions of years with complete indifference to whether anyone thinks it should straighten itself out. There's a lesson there, and it is almost rude in its calmness. When sunlight touches an asteroid, it does more than illuminate it. It warms the surface, sometimes quite dramatically between the lit side and the dark side, because there is usually no atmosphere to soften the contrast. On Earth, air and weather help distribute heat. Clouds interfere, winds gossip, oceans assist, and the whole planet acts like a giant thermal committee. An asteroid has no such management structure. Its day side bakes under direct sunlight, while its night side can become intensely cold. So every rotation creates not just changing views, but real cycles of heating and cooling, a stark but steady pulse of temperature. You can imagine a boulder on the surface spending hours in darkness, cold and still, then feeling sunlight creep over one edge as the asteroid turns. The shadow line moves. The rock warms. Perhaps tiny grains nearby expand a little with heat. Later, as the sun slips away again, the temperature falls and the surface contracts. Over vast spans of time, these repeated changes can stress the material, helping crack rocks, loosen grains, and slowly alter the texture of the surface. Even without weather, even without rain, an asteroid has a kind of thermal breathing. Sunlight comes. Heat enters. Night returns. The surface answers. That repeated cycle gives you one of the loveliest bedtime images in all of asteroid science. Sunrise on a world too small to hold air, too rough to be polished, and too ancient to care whether anyone is watching. There is no colorful sky because there is no atmosphere to scatter light. Dawn does not bloom in pink or gold across clouds. It arrives as a blade of sunlight. One instant the horizon is black, then a ridge catches fire with brightness. A boulder glows on one side and remains ink dark on the other. The landscape goes from absolute shadow to sharp illumination with a theatrical efficiency that would be ridiculous if it were not so beautiful. And because many asteroids are so small, the curvature can be intimate. A sunrise that would not feel like the slow unveiling of an enormous planet. It might feel like light spilling across the edge of a small, crooked room. Hills are low, horizons are near. The whole body is a compact stage for the movement of light. If you stood on such a surface, and again, leaving aside the absolutely exhausting issue of survival, you might watch the sun rise over a lumpy ridge on a world where gravity is so weak that a vigorous sneeze could become an unfortunate career decision. That weak gravity changes everything about the experience. On an asteroid, down is a very modest suggestion. You would weigh almost nothing. A jump could send you upward alarmingly far. Dust would settle gently, if it settled at all. The surface, depending on the asteroid, might be covered with loose regolith, broken stone, gravel, and boulders resting in arrangements that look casual but have lasted a very long time. Some asteroids spin so rapidly that their loose structure becomes an important question. If a rubble pile asteroid rotates too fast, its weak gravity may struggle to hold on its surface material. There seems to be a kind of speed limit for larger rubble piles, beyond which they may begin shedding material or reshaping themselves. That is a lovely detail because it turns spin into character. A body is not only moving, it is negotiating with its own structure. Stone, gravel, self-gravity, sunlight, history, all in one subtle conversation. Spin too fast, and the asteroid may adjust, redistributing material, perhaps forming an equatorial ridge where loose debris migrates. Even a humble space potato can have boundaries. And then there is the sunlight itself, which over immense timescales can do more than warm the surface. It can gently alter the asteroid's spin through a process known as the YRP effect, where the uneven absorption and re-radiation of sunlight produces tiny torques. Tiny, yes, embarrassingly tiny in the moment. But in the patient economy of the solar system, tiny repeated influences matter. Over long periods, sunlight can speed up or slow down an asteroid's rotation, subtly changing the way it turns. Imagine being nudged by light for millions of years until your spin is different. It is such a delicate idea that it hardly sounds real, and yet there it is, sunlight, not merely illuminating the stone, but helping write its rotational future. That can be deeply calming to think about. Even in the emptiness of space, with no atmosphere and no oceans and no seasons in the earthly sense, there are still rhythms and influences. Light is not passive. Time is not blank. An asteroid lives inside repeated cycles of brightness, darkness, warmth, cold, and gradual change. Its day may be strange, its sunrise knife-sharp, its gravity almost impolite in its weakness, but it still participates in the quiet logic of recurrence. Turn toward the sun, turn away. Warm, cool, continue. And maybe that is why these spinning stones feel so companionable tonight. Their lives are simple, but not empty. They know repetition. They know alternating light and shadow. They know how a surface can face brightness and then rest again in dark. They know that motion need not be dramatic to be meaningful. Sometimes it is enough to keep turning. So you let your mind rest on that image now. A rough asteroid slowly rotating through silence. One side entering day while another releases it, boulders taking their turn in the light, shadows sliding across ancient ground, the black sky unchanged, the sun steady, the stone continuing in its patient cycle. No atmosfere, no applausi, no rashi. Just the quiet dignity of an old object keeping time the simplest way possible, by turning its many imperfect faces toward warmth and then away again, over and over, as though even a lumpy survivor from the birth of the solar system deserved its own calm little sunrise. You stay with that slow turning, that patient little sunrise crossing a rough surface, and then you begin to wonder what exactly that surface is made of. What kind of ancient matter is actually sitting there in the light, warming and cooling, holding onto the memory of the early solar system in silence. And this is where asteroids become even more soothing, because their ingredients are simple in the most profound way. Stone, metal, carbon-rich dust, minerals that formed when everything nearby was still young. Nothing flashy in the modern sense, no neon labels, no polished packaging, no marketing department whispering that this object will revolutionize your life in 3 easy payments. Just matter, very old matter, arranged with extreme patience. Some asteroids are stony, built mostly from silicate minerals, the kinds of materials that also make up much of the rocky crusts and mantles of planets. These are the familiar bones of terrestrial worlds, the solid ingredients of geology before geology had weather, rivers, and mountains to fuss over them. You can think of them as cousins to the rocks under your feet, except far older in spirit, less revised, less rearranged, less dragged through the whole exhausting drama of erosion, plate tectonics, and life deciding to invent moss. Some are metallic, rich in iron and nickel, gleaming in the imagination like hidden vaults drifting in the dark. These asteroids feel almost mythical when you first hear about them, as though pirates were finally forced to become astronomers. But their metallic nature has an even calmer story behind it. They may be fragments of larger bodies that once heated enough for heavy metals to sink inward, forming cores, before collisions later shattered those parent objects and exposed their inner material. So a metallic asteroid may be, in a sense, the ancient heart of a body that no longer exists in one piece. A core without its former shell. A secret interior brought quietly into the light. That idea has a lovely gravity to it. Some asteroids are not just leftovers from the solar kitchen. They're deeper leftovers, pieces from inside early worlds that almost became more complete before fate, which in the solar system often takes the form of high-speed impact, rearrange the plan. You imagine a body warming long ago from radioactive decay and collisions, beginning to differentiate, separating into layers the way a larger rocky world might. Dense metal sinking inward, lighter rock rising outward. Then, at some point, a catastrophic disruption. The parent body broken apart, its interior scattered, some fragment surviving as a metallic asteroid billions of years later. It feels almost intimate, as though space occasionally reveals what is usually hidden. Then there are the carbon-rich asteroids, darker and often more primitive, carrying compounds that can include carbon-bearing material and minerals altered by water long ago. These bodies are especially gentle to imagine because they seem so ancient, so little transformed, like old pantry jars that still contain the first ingredients. They are dark, often reflecting less sunlight than stony or metallic types, and can appear almost soot-like in the imagination, though their darkness is not emptiness. It is fullness disguised as shadow. They may hold clues to water in mineral form, to organic chemistry, to the broader inventory from which the inner solar system was assembled. Quiet bodies, rich in history. And the diversity itself is restful. Asteroids are not all copies stamped from one cosmic mold. The solar system, from the beginning, worked with gradients of heat and composition. Closer to the young sun, certain materials condensed and survived. Farther out, other compounds could remain stable. Bodies formed in different neighborhoods, under different conditions, with different ingredients available. Later they moved, collided, scattered, and sometimes mixed. So when you look at the population of asteroids, you're seeing a collection of old recipes. Some rocky, some metallic, some darker and richer in carbon-bearing compounds. Some mixtures, some in-between cases, some with histories too complicated to fit neatly into one labeled drawer, which frankly makes them even more real. Scientists often sort asteroids into broad classes based on what their reflected light suggests about their composition. There are S-type asteroids, generally stony, associated with silicate minerals and nickel-iron metal. There are C-type asteroids, carbonaceous and dark, among the most common. There are M-types, often linked with metallic compositions, though reality always reserves the right to be slightly more complicated than the acronym suggests. And there are other classes besides, because the universe heard your desire for a simple system and responded with a patient smile and several exceptions. Still, the broad picture remains beautiful. Asteroids are a mineral map of the early solar system. You can almost feel the textures now. A stony asteroid, its surface strewn with broken rock, gravel, dust, perhaps the remains of countless tiny impacts. A metallic body, denser, perhaps reflecting light with a different kind of firmness, its material hinting at ancient internal structure. A carbon-rich asteroid, dark and soft-looking in photographs. Not literally soft perhaps, but visually quieter, as though it absorbs brightness and keeps its secrets politely to itself. None of them are luxurious by ordinary human standards. No velvet robes, no showroom lights, but they possess a deeper richness, authenticity at planetary scale. And minerals matter because minerals are memory with structure. A crystal lattice is not just arrangement. It is history frozen into form. Certain minerals tell you about heat. Others tell you about water. Others preserve the timing of formation, the conditions under which they came together, the environments they endured. In meteorites that come from asteroids, scientists have found tiny rounded inclusions called chondrules, grains and droplets that formed in the early solar system and were later incorporated into larger bodies. These are among the oldest materials in our cosmic neighborhood, small enough to fit in your hand if they arrive on Earth, old enough to make mountains look like fresh gossip. That is one of the most peaceful facts in this whole story. Something as modest as an asteroid can contain material older than any landscape you have ever seen. Not older by a little, older by absurd amounts. Older than oceans in their current form, older than continents as they are now, older than life, older than the moon's familiar quiet influence on Earth's tides. The mineral grains inside some astro-derived material formed when the solar system itself was still sorting out what kind of place it wanted to become. There are pieces of before held inside pieces of still. And then there is the dust. You cannot forget the dust. Asteroid surfaces are often covered in regolith, a blanket of loose broken material produced by impacts, cracking, shifting, and a long patient work of time without weather. It is not the cozy house dust of abandoned bookshelves and windowsills. Thankfully, no tiny lint empire. This is sharp, ancient dust, mineral dust created when rocks strike rocks and surfaces fracture under thermal stress. On a small asteroid, where gravity is weak, this dust may lie in surprising patterns, settling into low areas, gathering around boulders, shifting in response to tiny disturbances. The skin of the asteroid is often a record of slow breakage. There is something tender about that, too. Beneath the grand scale, asteroid surfaces are made of fragments. Pebbles, dust, broken stone, bits resting together on weak gravity. Their skins are not polished armor. They are accumulations of time. A spacecraft arrives and sees boulders the size of houses sitting on a small body whose whole gravity might barely insist on the concept of down. Fine grains nestle between larger rocks. Craters overlap. Ridges preserve old movement. The surface is humble, piecewise, and completely sufficient. And because asteroids keep such old material, they have also quietly entered one of the oldest human habits, wondering where we came from. Not in the emotional sense tonight, although frankly they support that too, but in the chemical sense. Carbon-rich asteroids and related bodies may have helped deliver water-bearing minerals and organic compounds to the early Earth. Not necessarily doing all the work themselves, because the universe loves collaboration when the project is billions of years long, but contributing ingredients to the young planet that eventually became home to oceans, weather, cells, and one day, somebody lying in bed, listening to a story about space rocks, and feeling unexpectedly soothed by them. So the asteroids are not merely archives. They may also be messengers. They carry the raw materials of worlds, and perhaps in some cases, of habitability. Their metals tell of differentiation and broken interiors. Their stones tell of the building blocks of rocky planets. Their carbon-rich bodies tell of primitive chemistry and ancient water interactions. Their dust tells of surface history, impact history, thermal history. Each one is like a sealed container from the early pantry of the solar system. And each container opens not with a dramatic hiss, but with a quiet revelation. This is what was there in the beginning. And that simplicity can settle your mind in a very particular way. Under all the complexity of planets, atmospheres, climates, biology, and human life, the universe keeps returning to a basic inventory. Rock, metal, carbon, minerals, heat, cold, light, time. Asteroids preserve that stripped-down list in some of its clearest forms. They do not hide behind oceans or forests or weather systems. They let matter be matter. They let composition speak plainly. So you imagine them now not just as shapes turning in darkness, but as textures of memory. Metallic hearts from shattered proto-worlds, dusty skins layered with old impacts, carbon-dark surfaces holding primitive compounds, stony bodies keeping the same mineral language that rocky planets still speak. Nothing wasted, nothing gaudy, just the ancient stockroom of the solar system still quietly in circulation. Each asteroid carrying its humble ingredients through the dark as though the first chapter of everything never really ended, only broke into smaller pieces and kept orbiting. You let those ancient ingredients keep circling in your mind for a moment. Stone, metal, carbon, dust, the patient stockroom of the solar system. And then your attention drifts a little closer to home, toward a group of asteroids that sound much more alarming than they usually deserve. Near-Earth asteroids. Even the phrase arrives with suspicious posture, as though it has practiced looming in a mirror. But once you actually spend time with these objects, the mood changes completely. They stop feeling like villains and start feeling like neighbors. Quiet ones, predictable ones, the kind who pass by on a regular route and never once ring the bell at an unreasonable hour. A near-Earth asteroid is simply an asteroid whose orbit brings it into the region of the inner solar system near Earth's orbit. That is all. Not a threat by default. Not a cosmic assassin. Just a body whose path happens to travel comparatively close to ours in celestial terms, which still often means millions of kilometers away, because space continues to be hilariously committed to scale. Near, in astronomy, can sound like the universe is trying to be technically correct while also trolling your instincts. A flyby can be called close enough to interest astronomers and still be far beyond anything that should disturb your blanket situation tonight. And what makes this whole topic so unexpectedly restful is that near-Earth asteroids are not unknown intruders slipping through the dark in trench coats. Many are well-tracked. Their orbits are measured, refined, rechecked, and monitored by astronomers who take this work very seriously, while somehow also managing to give these objects names that make them sound either elegant, mythic, or like someone's quietly mysterious cousin. The sky is not unwatched. That is perhaps the most comforting truth in this entire part of the story. Human beings have not just stared upward in vague concern and hoped for the best. We have built surveys, observatories, software, orbital models, and a whole steady system of attention. So you can picture it now. While most of the world goes about ordinary life, telescopes skin the night, picking up points of light that move slightly differently from the stars. A new object is noticed. More observations follow. Its path is calculated. Other telescopes join in. The orbit becomes clearer. The uncertainties shrink. The object goes from unknown to known. It gets folded into the great patient bookkeeping of the sky. There's something deeply soothing about that process. Not panic, not guesswork. Observation, math, update, repeat. The cosmos sends a moving rock through the dark, and humanity replies with careful notes. Some near-Earth asteroids are part of groups defined by the shapes of their orbits. Some cross Earth's orbit. Some come close without crossing it. Some spend most of their time farther out and then dip inward. Some remain mostly inside Earth's orbital distance from the Sun. The details are wonderfully specific and quietly elegant because orbits are never just heading our way in the cartoonish sense. They are full paths, complete ellipses shaped by gravity, timing, inclination, eccentricity, and the long conversation each object has with the Sun and planets. A near-Earth asteroid is not usually charging at Earth like a thrown rock. It is tracing its own lawful route through the solar system, sometimes intersecting our neighborhood, often nowhere near us at any particular moment. And that neighborhood metaphor really helps. Earth is not alone in the inner solar system. It shares the space with other small bodies that occasionally pass through the broader district. Some come and go on long schedules. Some make repeated visits. Some are discovered, tracked for a while, then observed again years later. Their return anticipated with the calm satisfaction of people who genuinely enjoy being right about orbital mechanics. The whole thing feels less like an ambush and more like trained timetables for ancient stones. There's also comfort in the language astronomers use when they identify objects that merit attention. Potentially hazardous asteroid sounds dramatic because English loves a little flair, but it does not mean a collision is about to happen while you're trying to relax. It is a classification based on size and how close an object's orbit can come to Earth's orbit. It is a way of saying this is worth tracking carefully, not this is the end of your herbal tea. The distinction matters. Science is full of labels designed for vigilance, not hysteria. And once you understand that, the whole field starts to feel more like watchfulness than fear. You can appreciate the beauty of that watchfulness. Humanity has become the species that notices the small moving stones of the solar system and keeps records on them. There is something almost tender about it. We are tiny ourselves, living on one rocky planet, under one atmosphere, around one star, and yet we have taught ourselves to detect dim objects millions of kilometers away and predict where they will be years from now. We have learned to look at a faint moving point against the stars and say, with increasing confidence, where it will go. Not because the universe promised clarity, but because patience found it. And some of these objects perform the gentlest little cosmic courtesy of flying by and then leaving, giving us a chance to study them up close from afar. A near-Earth asteroid may make a relatively close approach, pass through the region with complete indifference to our feelings, and continue on. No drama necessary, just motion. Astronomers gather data. Radar observations, in some cases, help refine the shape and orbit. Brightness changes reveal rotation. Spectra hint at composition. The object, meanwhile, keeps moving with the calm confidence of something that has never once checked social media. That repeated pattern can be oddly reassuring. Discover, track, refine, revisit. A body that once seemed like a vague point of uncertainty becomes a familiar entry in a catalog. Another neighbor whose habits are increasingly well understood. The unknown becomes mapped. The faint becomes characterized. The fearsome becomes, if not adorable exactly, at least manageable in the mind. That is one of the softest powers of science. Not making the universe smaller, but making it less lonely and less vague. Some near-Earth asteroids are especially interesting because they may be easier to reach with spacecraft than objects farther away. Their orbits bring them into ranges that human missions can realistically target, which turns them from abstract concerns into destinations. Imagine that for a moment. A body once filed under small moving point near Earth's orbit becomes a place a probe can visit, orbit, touch, or sample. The neighbor is not only tracked, but greeted. Human engineering stretches outward and says, in effect, hello there, ancient rock. May we have a closer look at your dusty face? And when that happens, the emotional tone shifts even more. It is hard to keep treating something as a monster once a spacecraft has arrived and calmly begun taking pictures of its boulders. A close-up has a way of reducing melodrama. Bennu, for example, turned from a distant object into a detailed landscape. Dark, rugged, scattered with rocks, shaped like a quietly complicated top. Ryugu, another near-Earth asteroid, became a place with ridges, craters, boulders, and texture. The nearer you get, the less they seem like doom, and the more they seem like geology with excellent orbital discipline. There's also the matter of time. Orbits are not snap judgments. When astronomers assess possible future close approaches, they project paths forward, sometimes over decades, sometimes longer, updating with every new set of observations. Uncertainty shrinks as knowledge grows. Occasionally, an object that briefly seemed a little more concerning turns out, after more data to be comfortably safe. This is not because anyone got lucky. It is because measurement improved. That process is almost medicinal to hear about before sleep. The unknown does not always need a dramatic resolution. Sometimes it just needs better data. And you can feel that principle working on your own nervous system too. A vague threat is often worse than a measured one. The mind dislikes fog and fills it with monsters. But near-Earth asteroids, once measured, become numbers and paths and timings and distances. They become understandable. Not trivial because attention matters, but understandable. And what is understood becomes easier to place within the larger calm. Even the flybys themselves can feel gentle when you imagine them properly. A dark stone passes through space, sunlight glancing off one turning side. Earth continues in its own orbit. The asteroid continues in its own. They come nearer than usual for a while, then separate again, each continuing under the same sun. No sound, no friction, no alarm in the cosmic sense. Just two bodies moving through a vast shared neighborhood, one inhabited and noisy, one ancient and silent. That silence matters. Near-Earth asteroids do not announce themselves with menace. They're quiet the way all small bodies in space are quiet. Their apparent drama comes mostly from our storytelling habits and our very understandable preference for not being hit by things. But underneath that entirely reasonable preference lies a calmer reality. Most of these objects are simply part of the solar system's ordinary traffic, and we are getting better all the time at knowing who is where and when. Watchfulness is growing. Surveys improve. Catalogs expand. The map of our local cosmic neighborhood becomes more complete, point by point. So as you rest there, you can hold on to the nicest version of this truth. Near-Earth asteroids are not faceless threats drifting in from nowhere. They are neighbors moving on long, elegant routes, increasingly known to us, increasingly familiar. Humanity has lifted its gaze and begun to keep company with them through observation, prediction, and patient care. The old stones pass by. We notice. We write it down. We learn their habits. And in that exchange, the darkness near Earth becomes a little less uncertain, a little more inhabited by understanding, as though even the quiet wanderers who come close are willing, in their stony way, to let themselves be known. You keep that feeling of familiar neighbors with you, the sense that even the stones that wander near Earth are more knowable than frightening. And then one of the sweetest surprises in the whole asteroid story quietly steps into view. Some of these little worlds are not alone at all. Out in the great black spaciousness, where everything seems built for solitude, some asteroids have companions. Tiny moons, paired partners, double bodies circling a shared center of gravity with such patience and delicacy that the whole arrangement feels less like mechanics and more like a waltz performed so slowly that only the universe has the attention span to appreciate it. This is one of those facts that instantly softens the cosmos. A lone asteroid is already strangely companionable, with its lumpy shape and its little sunrise and its dusty skin holding the memory of the early solar system. But an asteroid with a moon is something else entirely. It becomes a relationship, not emotional, obviously. No heartfelt conversations in vacuum. No pebble-sized anniversary cards. But still, a relationship in the cleanest physical sense. Two bodies responding to one another, each shaping the other's motion through gravity, however weak that gravity may be. And weak it often is. Asteroid gravity is not the commanding gravity of a planet. It is gentle, persuasive, the sort of gravity that clears its throat before asking you to stay nearby. That gentleness is part of what makes these systems so relaxing to imagine. A moon around a giant planet can feel grand, almost formal, like a cathedral procession. A tiny moon around an asteroid feels intimate. The primary body may be small, irregular, perhaps a rubble pile with the structural confidence of a bag of rocks, trying to maintain decorum. The moon may be far tinier still, a compact companion circling in silence. The entire system is modest. You could almost miss it if you did not know where to look. And yet there it is, a complete gravitational duet. Some asteroid systems are binaries, where two bodies orbit a common center of mass. Sometimes one is clearly larger and the other smaller, like a parent body with a moon. Sometimes the two are closer in size, creating a more equal partnership, each one circling not the other exactly, but a point in space between them. That is one of the loveliest concepts in orbital mechanics. Two objects can be bound together, not because one utterly dominates, but because both participate in a shared balance. They revolve around a common center, a kind of invisible compromise. It is hard not to find that charming. There are even systems where the pair is so evenly matched that they feel like twins drifting together through the dark. The asteroid Antiope is a famous example of a double system with two similar-sized lobes orbiting each other. It gives off the unmistakable vibe of two ancient stones that have decided the universe is too large to do this separately. They circle their common center with perfect seriousness, like dancers who never miss a step because the dance itself is simply gravity being honest. And then there are asteroid moons, smaller companions that orbit a larger primary. Ida, for instance, has a tiny moon called Dactyl, one of the early discoveries that made people look at asteroids with fresh tenderness. A small, irregular body, already endearing, accompanied by an even smaller companion. It is almost unfairly cute for something happening in a place with no air and no sound. Later observations revealed that many more asteroids have satellites. Some large, some tiny, some in surprisingly stable arrangements. The lonely space potato, it turns out, occasionally arrives with a +1. What makes these pairings possible is the same quiet power that shapes everything else in this story. Gravity, but scaled down to a whisper. On Earth, gravity feels bossy. On a planet, it is the rule of the room. On an asteroid, it is barely a suggestion and yet still enough, over time, to hold pieces together, keep moons nearby, and organize motion into graceful loops. That is the deeply calming part. The force does not need to be loud to be effective. A faint pull, repeated constantly, can choreograph an entire system. The little moon circles. The primary turns. The pair continues around the sun. No drama, just persistence. And because asteroid gravity is so weak, the ways these companions form can be especially delicate and interesting. Sometimes a collision may blast material off an asteroid, and some of that debris may not escape entirely. Instead, it may settle into orbit and gradually gather into a moon. Other times, sunlight itself can play a role. Over immense timescales, the gentle influence of sunlight can alter an asteroid's spin, and if a rubble pile body spins fast enough, loose material may migrate, shift, or even separate, potentially leading to the formation of a small companion. Imagine that. Not a violent cosmic announcement, but light, time, weak gravity, and loose stone quietly rearranging a body until it develops a moon. The universe can be so subtle, it almost feels like it is showing off. That process is especially beautiful because it turns earlier ideas back toward one another. Remember those rough shapes, those rubble piles, those little sunrises and thermal cycles. None of those details stay isolated. The odd shape matters. The loose structure matters. The spin matters. Sunlight matters. Given enough time, these influences can produce not just a solitary asteroid, but a miniature family. A primary body and a companion. Each one evidence that even in the emptiness of space, relationships can arise from repeated gentle effects rather than grand declarations. Some asteroid systems go further still and become trios. A larger body with two moons. Cleopatra, that extraordinary dog-bone-shaped metallic asteroid, has a pair of small moons, which makes it feel less like a single object and more like a tiny private solar system with a very eccentric host. Even here, where the shapes are bizarre and the scale is small, the same basic pattern appears again. Bodies in orbit, Mutual influence, gravitational companionship. The cosmos likes repetition. It keeps using the same elegant rules, whether it is arranging planets around a star or little moons around a lumpy shard of ancient metal. And the visuals of these systems are so gentle if you let yourself really picture them. A tiny moon making its way around an uneven asteroid whose surface is scattered with boulders. The primary slowly rotating beneath it. The whole pair bathed in sunlight on one side, blackness on the other. No sound, no atmosphere, no rusing. The moon completes its orbit not in grand planetary majesty, but in quiet proximity, as if circling a dear old ruin. Some orbits are close and quick, others are wider and slower, but all of them have that same patient grace, one body repeatedly finding its path around another, held by a force neither can see and neither can ignore. There's also something soothing about how vulnerable and stable these systems can seem at once. Because the gravity is weak, you might assume everything is on the verge of floating apart in embarrassment. But many of these pairs remain bound over long periods, their motions balanced, their orbits predictable. Stability does not require brute strength. Sometimes it only requires the right arrangement. That is a very bedtime kind of truth. Not everything enduring needs to be heavy-handed. Some things last because they fit. And of course, their companionship changes how each body experiences its little world. A moon orbiting an asteroid may rise and set in the black sky above the primary surface. Imagine standing on that lumpy ground again, under the airless dark of asteroid daytime, and watching a tiny companion move overhead. No clouds, no blue. Just a small, irregular moon, perhaps not even spherical, gliding slowly across the stars while the primary turns below it. On the moon itself, the primary would loom large in the sky, enormous compared with what Earth's moon looks like to us, because the whole system is compact. Each body becomes part of the other's landscape. That mutual presence feels profoundly calming. Even in the cold emptiness, something is there. A companion overhead. A repeated motion, a reminder that orbits create familiarity. The moon passes again and again. The primary remains where it is expected to be. The geometry becomes routine. Routine, even in space, is one of the great sedatives. The scientific beauty of these systems is that they reveal interior structure, mass, density, and history. By watching how companions move, astronomers can infer how much mass the primary has and how loosely or tightly it may be assembled. But even before any calculation, there is emotional beauty in the mere fact of companionship. The asteroid is no longer just one old stone drifting under sunlight. It is a pair, a dialogue of motion, a proof that even weak gravity, given time, can create something that looks almost tender from a distance. And perhaps that is why asteroid moons feel so memorable. They scale the grandeur of the universe down to something nearly domestic. Here is a small body. Here is its tiny companion. Here is their shared center. Here is the path repeated in silence. Nothing in the arrangement is loud, and yet everything in it is meaningful. The primary does not have to be large to host a moon. The moon does not have to be round to be beautiful. They only need to keep answering each other through gravity. So you rest there with the image of them. Little paired worlds circling together in the dark. Old stones that found themselves bound not by spectacle, but by persistence, each one moving around an invisible center with quiet fidelity. The solar system, for all its vastness, keeps making these small, intimate patterns. Not just stars and planets, not just belts of ancient debris, but companions. Tiny moons, double asteroids, tranquil gravitational waltzes carried on for ages without music, without witnesses, without ever missing the step. You keep that slow gravitational waltz in view for a moment longer. The tiny moon passing overhead, the primary waiting below it like an old stone host, and then another kind of tenderness arrives, one that feels almost impossibly human. Because eventually, after all the watching and cataloging and wondering, you do not remain at a distance. You send machines. You build careful little ambassadors of metal, code, patience, and hope, and you ask them to travel out across the dark to meet the asteroids in person. And somehow, among the most relaxing facts about these ancient stones is that humanity has not only looked at them, but gently reached them. There's something so disarming about that. A rocky body older than Earth's oceans drifts through space in complete silence, minding its ancient business. And from one small blue planet comes a spacecraft moving with exquisite precision, crossing millions upon millions of kilometers just to draw near, to look closely, to orbit, to map, to land, to touch. Not to conquer in the old loud sense. Not to plant a flag and start giving everything self-important speeches. Just to visit, just to learn, just to place a small mechanical hand on the shoulder of deep time and say, very softly, hello. And the closer you get to these missions, the gentler they feel. Spacecraft do not arrive at asteroids with swagger. They arrive with caution because asteroids are small, oddly shaped, weakly gravitating, and absolutely unwilling to make anything easy for your navigation software. A planet is large enough to behave somewhat like a planet. It has a clear center, a stronger pull, a larger target area, a certain cooperative grandeur. An asteroid is more like trying to rendezvous with a quietly rotating pile of rubble the size of a mountain, while everyone involved remains very polite. It is delicate work, which somehow makes it more beautiful. The first close visits changed everything. When spacecraft flew past asteroids and sent back detailed images, the old idea of these objects as anonymous points of light quietly dissolved. Suddenly you could see craters, boulders, grooves, ridges, shadows cast across irregular surfaces. A body that had once been just a moving dot became a place. Not a metaphorical place, a real one, a terrain with texture, a world small enough to fit into human thought and ancient enough to humble it completely. The asteroid stopped being generic and became itself. Take Eros, for instance, visited by the near Shoemaker spacecraft. From far away, it was an asteroid. From close up, it became a long, battered landscape of craters and regolith, a stretched, weatherless body carrying the marks of an immense history. And the mission did not stop at observing from a respectful distance. It eventually landed gently on the surface. That word still feels almost miraculous in context. Landed on an asteroid, on a lumpy, ancient object whose gravity is so weak it can barely insist on what down means. There is something almost whisper-like in that achievement. Not a thunderous touchdown, but a careful settling. Then there was Hayabusa, the Japanese mission that visited Itakawa, that endearingly strange little peanut-shaped asteroid you can hardly picture without developing immediate affection for it. Itakawa turned out to be a rubble pile, a body assembled from fragments, a contact binary sort of survivor with rough terrain and boulder-strewn surfaces. Hayabusa did more than look. It touched the asteroid and later returned tiny samples to Earth. Tiny. That is one of the details that makes the whole thing feel so intimate. The sample did not have to be large to be precious. A few grains from an asteroid can hold a chapter of the solar system's autobiography. There is real comfort in the humility of that exchange. Human beings did not need to drag home half a mountain to prove the point. A few microscopic particles were enough. That is how rich these objects are in meaning. A speck of asteroid dust, gathered by a spacecraft after a journey across space, can tell you about mineralogy, thermal history, surface processes, and the evolution of small bodies. A grain can carry ages. And then came the missions that deepened that quiet relationship. Dawn visited Vesta and Ceres, moving not just toward one destination, but from one ancient body to another, like a patient traveler in the oldest district of the solar system. Vesta appeared as a differentiated world scarred by a colossal impact, with enormous basins and grooves that make it seem at once wounded and stately. Ceres, larger and rounder, revealed bright salt deposits, a mysterious and calm beauty all its own, almost like a body that had decided to become something between asteroid and world, and then keep the distinction politely ambiguous. Dawn did not rush. It orbited, studied, mapped. It allowed these bodies to become landscapes in the human mind. And what a soothing thing mapping is when you think about it. A spacecraft approaches something old and strange, and instead of simply gasping at it, it begins the quiet work of familiarity. Here is the crater. Here is the ridge. Here is the bright deposit. Here is the shadowed slope. A world that existed for billions of years without a name for any of its features suddenly receives careful attention. Human curiosity starts labeling the wrinkles of deep time, not to own them, but to remember them properly. Then there's OSIRIS-RX, which traveled to Bennu, that dark, rugged near-Earth asteroid with its top-like shape and unexpectedly boulder-covered surface. Bennu had been imagined one way from a distance and turned out to be rougher, rockier, and more exuberantly cluttered up close, which feels very on-brand for asteroids generally. They love to remind you that reality is more textured than your first assumptions. The spacecraft studied Bennu in detail, mapping hazards, measuring its spin, watching particles leave its surface, and eventually descending for a brief touch-and-go sample collection. The contact was so gentle and yet so consequential that it feels like the scientific version of brushing dust from a library shelf and accidentally finding the first page of history. Ryugu received a similarly delicate visit from Hayabusa 2, another triumph of quiet determination. This asteroid, dark and rough, became the site of careful study, surface touchdowns, small deployed rovers, and sample collection. Think about how astonishingly calm that is when stripped of jargon. You send a machine across interplanetary space. It arrives at a tiny, rotating body. It studies the terrain. It sends little explorers onto the surface. It gathers grains. It leaves. It comes home. The whole mission is a masterpiece of patience pretending to be engineering. And perhaps the most restful part is that the spacecraft themselves must adapt to asteroid reality. They cannot behave as though they are landing at an airport with predictable gravity and a nice broad runway. Around an asteroid, orbiting and maneuvering are subtle. The gravitational field can be uneven because the shape is irregular. Surface properties can surprise you. Loose regolith can behave in unexpected ways under disturbance. Rotation matters. Illumination matters. Everything matters in small, precise ways. So the missions proceed carefully, step by step, as though they know they are visitors in a place where speed would only be vulgar. That care gives the whole story a nearly ceremonial quality. Approach, observe, measure, adjust, descend, touch, retreat, analyze, return. It is not the language of conquest. It is the language of listening. Spacecraft at asteroids are listening with cameras, spectrometers, altimeters, radio signals, sampling heads, and astonishing restraint. They are learning how these ancient bodies are assembled, how their surfaces behave, how their materials compare to meteorites found on Earth, how sunlight nudges them, how dust moves, how rubble piles hold together, how the earliest ingredients of the solar system remain stored inside small and humble forms. And every mission adds detail to the portrait. Asteroids are not abstract leftovers anymore. They are places with specific slopes, specific boulder fields, specific textures. You know that Bennu can shed particles. You know that Itakawa is rubble-like and surprisingly sparse in smooth areas. You know that Ryugu is dark and rough and full of history in miniature. You know that Vesta is proud and scarred, that Ceres is salt-bright in places, that Eros received a human-built visitor that rested on its surface. The family of asteroids grows not only in catalog size, but in intimacy. This intimacy matters because it changes the emotional scale of the universe. It is one thing to say that asteroids are ancient. It is another to know that a spacecraft has hovered above one, while its cameras traced the shadows of individual rocks. It is one thing to say that they preserve the early solar system. It is another to hold, in a laboratory on Earth, a sealed sample capsule containing grains from one of those bodies. Suddenly the gulf between you and deep time narrows. Not completely, never completely. Space keeps its grandeur. But a bridge appears, and that bridge is built from some of humanity's finest instincts: curiosity, patience, precision, and the willingness to cross vast distances for understanding rather than dominance. You send a machine outward, and it returns not with treasure in the ordinary sense, but with context, with evidence, with little pieces of an ancient stone that help explain how worlds were built and how leftovers endured. It is hard not to find that noble in the quietest possible way. So you imagine it now, a spacecraft drifting beside a rotating asteroid, matching pace with a body older than nearly anything familiar, sunlight flashing off solar panels, shadows moving across boulders below, radio signals taking their time across space. The machine descends slowly, touches dust that has waited billions of years, rises again, and carries that touch home. No applause in vacuum, no grand declaration, just one old stone allowing itself to be known, and one small species proving, with immense gentleness, that it can reach across the dark and meet the ancient quiet face to face. You keep that image of the spacecraft beside the asteroid for a while, the little human-made visitor floating near a body older than oceans, their motions matched in a silence so complete it almost feels holy, and then, very gently, everything widens again. The missions, the moons, the potato shapes, the dark carbon-rich dust, the metallic hearts, the main belt's impossible spaciousness, the little sunrises on airless stone, all of it begins to settle into one larger feeling. The most relaxing fact about asteroids may be that they show you how the universe keeps going without ever needing to rush. That sounds simple, almost too simple, until you really let it rest in your mind. These bodies have been circling the sun for billions of years. Billions. Not a poetic exaggeration, not a sleepy approximation, but truly immense spans of time in which they have continued along their paths while stars shifted slightly, planets rotated tirelessly, mountains rose and wore down, oceans changed, life emerged, vanished, and emerged again, and eventually you arrived here, in one room, on one night, listening. Through all of that, the asteroids kept orbiting. They did not hurry toward completion. They did not panic over delay. They did not confuse movement with urgency. They simply continued. And there's a deep peace in that kind of continuity. Your own days are full of clocks, reminders, deadlines, pings, batteries, passwords, errands, things due tomorrow, things overdue yesterday, and the vague but persistent sensation that everyone else has somehow already figured out how to be effortlessly organized while you're still trying to remember where you left your calm. Asteroids offer a different model. They move, yes, but they move in patient obedience to gravity and time. Their existence is not frantic. It is steady. Their routes are long enough that haste becomes meaningless. You can think of an asteroid orbit as a kind of cosmic sentence written without punctuation marks of alarm. Around and around the sun, sometimes more circular, sometimes more stretched, sometimes tilted, sometimes crossing the paths of planets, sometimes dwelling far out in quieter reaches. Always movement. Never hurry. The same laws hold. The same star shines. The same great pattern persists. And all the while, these little bodies, leftovers, fragments, survivors, witnesses, remain part of the architecture. There's comfort, too, in how small they are without being insignificant. This may be one of the gentlest lessons in the whole story. The universe does not reserve meaning only for the largest things. A star can be magnificent, a planet can be beautiful, but so can a rough, lumpy asteroid turning in silence. A tiny moon can circle a space potato and become unforgettable. A few grains of sample dust can tell you where worlds came from. A dark little object can preserve ancient carbon compounds and quietly hold a memory older than Earth's familiar landscapes. Size is not the same as importance. Loudness is not the same as value. The asteroids make that point over and over without ever giving a speech about it, which frankly only strengthens the argument. And because they are small, they also make the universe feel more personal. The grand scales of astronomy can be overwhelming. Galaxies, nebulae, stars so large your brain responds by politely leaving the room. But asteroids belong to a more intimate scale. You can imagine their contours. You can learn their names. You can remember which one is peanut-shaped, which one has a tiny moon, which one is dark and boulder-covered, which one has the bright salt scars of quiet chemistry, which one offered up grains that travel home inside a capsule through the atmosphere to a waiting team of human hands. They are cosmic, yes, but they are also almost touchable in the imagination, ancient without being remote in spirit. That intimacy changes your place in the story too. You are not outside this universe, studying it from some detached balcony. You are part of the same system. The iron in your blood, the silicon in rocks, the carbon in your body, the metals and the devices humans built to visit asteroids. All of it belongs to the same long inventory. The solar system is not a museum you visit. It is the neighborhood from which you are made. And asteroids, those old preserved leftovers from the beginning, are not strangers in that neighborhood. They are cousins of the material under your feet, distant relatives of the world that carries you. Once that thought lands, it can be extraordinarily soothing. The asteroids are not just out there. In a sense, they are part of the same ancient matter story that became you. The early solar system mixed, separated, collided, preserved, delivered, and transformed materials until one branch of that long process resulted in Earth, and much later in life, and much later still in someone capable of lying in the dark and feeling comforted by the notion of a spinning stone millions of kilometers away. The distance is real, but so is the kinship. You belong to the same patient construction, and that construction has always included imperfection. Remember those misshapen bodies, those rubble piles, those contact binaries like cosmic snowmen made of stone. Remember the main belt, not crowded and chaotic, but spacious and calm. Remember the weak little gravities that still manage to hold moons close. Remember how sunlight itself can nudge a rotation over immense spans of time. Remember that some asteroids are the exposed metallic hearts of broken early worlds, while others are dark pantry jars still holding primitive ingredients. The whole story is built from irregularity, survival, subtle forces, and time. Nothing needed to be tidy to become beautiful. Nothing needed to be finished to matter. Nothing needed to be perfect to last. That may be the most personally comforting part of all. The asteroids do not suggest a universe obsessed with polish. They suggest a universe that keeps what endures. A universe that allows fragments to remain. A universe that can turn leftovers into archives and rough shapes into wonders. If even a lumpy rubble pile can spend billions of years quietly circling the sun and become worthy of close study, then perhaps existence is gentler than your most anxious thoughts allow. Perhaps being unfinished does not remove you from the pattern. Perhaps carrying old scars does not separate you from beauty. The asteroids, in their stony way, have been making that case the entire time. And then there is scale, that great relaxer of human drama. In the company of asteroids, your timeline softens. The problem from this morning begins to shrink. The awkward conversation, the unread message, the unfinished list, the thing you should have said, the thing you wish someone else had not said. All of it remains real, of course. Bedtime comfort is not the same as denial. But next to an object that has turned through sunlight for hundreds of millions or billions of years, human urgency loses some of its sharpest edges. Not because your life is trivial, but because it is held inside something larger and steadier than panic. The universe keeps very old company. It is not alarmed by one unfinished day. You can feel that in the orbits themselves. Every asteroid path is a promise kept repeatedly. Come around again. Pass through shadow again. Turn the bright side toward the sun again. Continue. That repetition is not boring. It is reassuring. It means the cosmos has forms of reliability far older than any schedule humans have invented. The sun will be there. Gravity will still do its quiet work. The old stones will keep to their routes unless nudged, and even the nudges follow laws. This is not a universe of random shouting. It is a universe of patterns large enough to cradle uncertainty without collapsing into it. And maybe that is why people are drawn to the night sky in the first place, even before they know the names of what they are seeing. Somewhere inside the body, perhaps somewhere older than language, there is relief in looking up and sensing order. Not control, not simplicity, but order. The stars rise and set. The moon changes shape. Planets wander. Asteroids glide invisibly but faithfully through their domains. The sky is not static, yet it is not incoherent. It moves with memory. And once you know the asteroids are part of that movement, the darkness overhead feels even more inhabited by patience. The last and softest truth is belonging. Not ownership, not dominance. Belonging. You belong to a world made from the same old stock of matter as these ancient bodies. You belong to a species that learned to notice them, track them, name them, visit them, and carry grains of them home. You belong under a sky that contains not only blazing stars and grand planets, but also quiet leftovers from the beginning. Small, enduring stones that never asked to be dramatic and yet became, through their calm persistence, one of the loveliest things to think about before sleep. So you let everything gather now. The early solar kitchen with its crumbs still circling. The main belt with all that room to breathe. The funny potato shapes and contact binaries. The little airless dawns. The metallic cores and carbon dark surfaces. The near-Earth neighbors whose paths are watched with care. The tiny moons performing their gravitational waltzes. The spacecraft arriving like respectful guests. All of it folds inward into one final image. A vast, old, beautifully ordered neighborhood in which even the smallest stones have a place, and in which motion does not require hurry to be meaningful. And because the universe does not hurry, maybe you do not have to, at least not tonight. The asteroids have spent ages proving that continuation can be gentle, that survival can be quiet, that remaining in orbit is, in its own way, a kind of grace.